Welcome to this explainer. Let's jump right in, because today we're exploring one of the absolute most thrilling and honestly turbulent moments in all of human history, the birth of the modern city. Before the 18th century, architecture was fundamentally boxed in by the physical limits of timber, stone, and heavy masonry. But then, almost overnight, the world was violently shifted from localized rural craft to mechanized urban manufacturing. Today, we're unpacking exactly how the Industrial Revolution forged the architectural DNA of the world we live in right now. So grab your notebooks, because this is going to be a fascinating ride.
Here's a quick look at our visual syllabus for today, so you can structure your notes. We'll start with the catalyst, move right into the tectonic shift, break down the architectural characteristics, look at some prominent landmarks, and finally explore the urban consequence.
Section 1. The catalyst. Sparks of a shift. Okay, I want you to imagine the intense, almost overwhelming sensory experience of early, completely unplanned factory towns like Manchester or Leeds. Just look at the towering chimney stacks totally dominating the skyline here. Manchester was actually nicknamed Cottonopolis because it had this massive, sprawling concentration of cotton mills. And keep in mind, there was absolutely no grand urban planning happening here. No elegant boulevards, right? Instead, it was this sudden, chaotic landscape of raw industry, choking smoke, and super cramped populations. The air pollution from the factories and slaughterhouses was so intense that over in London, the stench from the Thames River often made working inside the Parliament building literally impossible.
Now, understanding why architecture had to change so suddenly is absolutely crucial. See, the transition to steam power meant factories no longer had to be built right next to fast-flowing rivers. They could be built anywhere, and that led to a massive rural-to-urban migration as people flooded in seeking higher factory wages. But there was a massive problem. The air inside these new textile mills was thick with highly flammable cotton fibers. When you combine that with traditional wooden-framed buildings, well, it was a literal recipe for disaster. These mills were constantly catching fire and burning straight to the ground. So this severe, everyday fire danger forced a sudden, desperate need for a totally non-combustible architectural innovation.
Section 2. The tectonic shift, a material revolution.
The pace of this revolution is it's staggering. In 1779, we get the very first cast iron bridge. By 1796, the first iron-framed building pops up. Skip ahead to the mid-19th century in 1851, and we have these vast, sweeping glass and iron exhibition halls like the Crystal Palace. And by 1884, we are literally scraping the sky with the very first steel-framed skyscraper. In just over a single century, the entire capacity of human engineering was completely transformed.
So what is the science behind this wild timeline? It really comes down to one thing: structural metallurgy. For centuries, metals were pretty much just used for secondary ornamentation, decorative stuff. But mass-producing iron in bloomery furnaces changed the game entirely. First up was cast iron. Now, it was brittle and weak in tension, but it had incredible compressive strength and could be mass-produced in all sorts of complex shapes, which made it absolutely perfect for factory columns. Then came wrought iron, which is a bit more ductile, and finally, by the late 1800s, structural steel took over the scene, offering unparalleled strength in both tension and compression, a real game changer.
To really grasp this tectonic shift, we need to compare the mechanics. Traditional heavy masonry relied completely on thick stone or brick walls to bear all the weight of the building, and because of that, you could only have very small windows. But metal skeletal frames, they completely changed the rules of gravity. By using an internal skeleton made of thin iron columns and beams, the exterior walls no longer had to carry the whole load. They were just hanging there. This allowed for massive interior spans, heights we'd never seen before, and the use of standardized, prefabricated parts that could be built off-site and assembled super quickly.
Section 3. Architectural characteristics, new design hallmarks.
So, engineered precision officially replaced traditional, localized handicraft. If you're taking notes, the key characteristics of this era are internal skeletal framing, prefabricated standardization, which is where rolling mills pumped out standard profiled sections to completely eliminate time-consuming custom cutting, and, crucially, non-combustible fireproofing. Notice how this kind of structural rationality gave civil engineers the power to design these vast, wide-open spaces that were quite literally impossible before. We're talking massive factory floors and the soaring, wide-span roofs of the great railway cathedrals.
And this leads us to one of the most beautiful outcomes of the whole era: vitreous architecture. Vitreous just means glass-like. Now, for centuries, glass was this rare, total luxury material, usually produced in small, wavy, inconsistent sheets. But the Industrial Revolution transformed glass into a ubiquitous, mass-produced building component. When you pair massive sheets of standardized plate glass with those slender iron frames we just talked about, you get structures that prioritize extreme transparency and light. It fundamentally blurred the line between the inside and the outside, totally paving the way for the modernist curtain walls we see on skyscrapers today.
Section 4. Prominent landmarks defining the 19th century.
Remember that massive problem of highly flammable textile mills we uncovered earlier? Well, here is the brilliant solution. Built in 1796 in Shrewsbury, the 5-story Ditherington Flax Mill is widely considered the grandfather of skyscrapers. By using an internal skeleton of slender cast-iron columns to support the floor loads, the engineers completely bypassed the need for massive interior masonry. This conserved precious floor space, and most importantly, it created a totally fireproof structure.
By the mid-1800s, this rapid industrialization led Benjamin Disraeli to famously dub Britain the workshop of the world. And honestly, he hit the nail on the head. The nation's global dominance in manufacturing and railway distribution meant they really needed a way to show off their incredible industrial might to the rest of the globe.
And what better way to show off than with this? The Crystal Palace. Designed by Joseph Paxton for the 1851 World's Fair in London, it was an absolutely immense, prefabricated glass and cast iron structure. Just put yourself in the shoes of a 19th century citizen walking into this colossal, glittering glass house for the very first time. You're surrounded by vast, transparent panels and delicate webs of iron. It was mind-blowing. It was the ultimate proof of the aesthetic and structural power of mass production and vitreous architecture.
All right, let's cross the Atlantic for a second. It's actually fascinating how a tragedy sparked an architectural revolution over in America. The 1871 Great Chicago Fire completely devastated the city. But from the ashes, it accidentally became the ultimate catalyst for experimentation. Out of that ruin rose the Chicago School of Architecture. This was a movement of forward-thinking architects and engineers who totally abandoned traditional heavy masonry and fully embraced steel skeletal framing to achieve vertical rather than horizontal urban growth. The absolute crowning achievement of that movement was the Home Insurance Building, constructed in Chicago between 1884 and 1885. It is widely regarded as the world's very first true skyscraper. By utilizing a revolutionary structural steel frame, this specific building essentially set the stage for the towering, modern steel skylines that define cities all over the world today.
Section 5. The urban consequence. Rapid urbanization.
Now we have to look at the darker side of this. The rapid growth of these cities created a stark, horrifying divide. The middle class lived in spacious, edge-of-town housing with relatively clean air. But the working class, the actual people powering the factories, they were forced into incredibly cramped, back-to-back slums. There was no plumbing, no ventilation. Entire streets of 20 houses or more would share a single water pump and a single privy. And those privies would inevitably overflow, turning the muddy courts between houses into literal open sewers that seeped right into the drinking water. It was a terrifying public health crisis, leading to rampant, absolutely devastating outbreaks of cholera and typhoid.
Eventually, civic leaders realized something pretty quickly. Disease does not respect class boundaries. The contaminated air and water eventually threatened everyone. So, this desperate need to cure the disease and chaos of the industrial metropolis is actually what birthed modern urban planning. First came legislative interventions, like the Public Health Act of 1875, which finally forced underground sewerage and strict sanitation standards. Then came the City Beautiful movement, heavily influenced by the Parisian Beaux-Arts style, attempting to bring classical civic order and grand, sweeping boulevards back to chaotic towns. And finally, we see Ebenezer Howard's Garden City movement, which proposed highly organized green belts and spatial planning to ensure healthy, breathable living conditions.
So, that brings us to the ultimate question I want to leave you with today. The Industrial Revolution didn't just give us the steel frame and plate glass. It gave us zoning laws, building codes, sanitation systems, and the entire concept of urban planning. If this era birthed both the soaring, brilliant glass skyscraper and the devastating disease-ridden urban slum, how does its legacy continue to shape the very streets you walk today? Next time you step outside, really look around your city. Look at the steel beams, the zoning of your neighborhoods, and the green parks. You'll see the permanent DNA of the 19th century literally everywhere. Thanks so much for joining me on this explainer, and keep exploring.